All right, so the next piece to this is going to be taking the equation itself and trying to figure out what the asymptotes or the things missing from the domain are using algebra. All right, and it's not a complicated thing to do. It really doesn't involve any extra knowledge that we should currently have, other than realizing how to take a couple things and put them together. All right, so the denominator is not supposed to be zero. All right, denominator is not supposed to be zero. All right, any value that makes the denominator equal to zero is a value that is not in the domain and a vertical asymptote. All right, which we've already kind of talked about in the last section. If you did those problems, we didn't make the direct correlation, but if there was an asymptote, then it wasn't in the domain. We talked about that. All right, so that's where these come from. All right, when the denominator is zero, so I'm going to write bottom. When the bottom equals zero, we get an asymptote. A-S-Y-M-P-T-O. I always have to think about spelling that word. Asymptote and not in domain. Okay, and hopefully that's fairly explanatory, because if the denominator cannot be zero, all right, we're finding the x values that make the denominator zero, all right, which would mean those are the values that x cannot be because they make the denominator zero and violate this rule. It all kinds of pieces together. All right, so what we're going to have to do is we're going to take the expression, all right, from the bottom, set it equal to zero, and solve it, which is going to be very, very simple sometimes, maybe a little bit more complicated. It's probably going to involve factoring when we do it on some form of an assessment or something that we're going to have to talk about and get graded. All right, that's what we're going to look to do. All right, very simple though. Take the denominator, set it equal to zero. Those are the values that would be your asymptotes, and they're missing from the domain.